like your questions, Jeff.
Hello, and thank you very much for joining today for the next episode of 9 Steps to Future-Proofing Your Warehouse. This is session 5, so thank you if you've joined and this isn't your first episode. Today we'll be looking at replenishment in another episode of looking at future solutions that can help you to future-proof your warehouse. Again, I'll be joined by the Fuzzy Logics team, who are our automation experts. So both Jeff and Baz will be joining us this time. And this time we'll also be joined by Swisslog, which is Paul Stringelman. And he will be joined by Graham Faulkner, who they're working with at JCar Electronics. So without further ado, let's get started. As per usual, we will be starting with Jeff, who will be going over an overview of the sector, and then we're passing over to Paul to give us some insights on that current project they're working on. So over to you, Jeff.
Good afternoon, and welcome to session number 5 of our 5-part series. Today, we'll just jump straight into it. If we can, Dan, thank you. So we'll go to the first slide. It's great to have you joining us for another week. It's been quite a great challenge putting these all together, and we hope that you're enjoying them. And please don't forget to tell your friends and colleagues about the sessions that we're running. We really do have a commitment to sharing as much knowledge as we can with the industry, and the more the merrier. So let's get straight into it. Today we'll be looking at replenishment, which is all about getting product into the pick face efficiently. So if we can go to the next slide, please, Dan. Okay. Now, as always, we go over the functional process itself. So we're up to functional process 4, which is replenishment. And replenishment refers to the restocking of a pick face location from reserve storage. Now, this can also be from a secondary pick face location. We'll talk about this a little bit later. But most of the time, we're talking about moving it from reserve storage to where you're going to be picking it from. Now, both the physical attributes of a pick face as well as its velocity are the key factors driving replenishment frequency. Pick face, now when we're talking about the pick face itself, we can be talking about pallets, cartons, or eaches, which is cartons is full case, eaches is split case. When we're replenishing a pick from pallet location, we'd be replenishing a pallet, and likewise, if we're replenishing a full case location, we're probably replenishing pallets or cartons. However, when it comes to split case, we usually find that a decant process is required. Now, it sometimes does make sense to have multiple pick faces for one SKU, but most of the time we want to reduce this. Decant itself refers to the removal of product from a shipping unit into a picking unit. It usually involves the creation of packaging waste, which needs to be managed. And this is kind of one of the topics that we'll be tracking as well as we go into automation. So if you think about when you're decanting into a shuttle-based system, you need to pull things out of cartons and put them into totes, and there's trash that's generated from that. Now, when we're talking about best practice tips, I always talk about the toolkit that we equip you with. What we're trying to do as we're analyzing this process and coming up with the best replenishment strategy for your business. We want to minimize unnecessary travel and touches, and get the product onto the pick face with the least amount of touches. Replenishment can involve multiple non-value-adding touches. The goal is to get the maximum efficiency out of each one. And that's why you use velocity-based replenishment strategies. With the advent of automation technologies, we have had to worry less about our pick face slotting and more about our replenishment management of these automated systems. You can put the wrong SKU into automation and find yourself chasing your tail with replenishment quite quickly. And that's why we have to make sure we engineer the location of each SKU in your warehouse. So, and the last point that we make there is about the minimum order quantities and your reserve quantities. And that's around making sure that you have a unit that you can move efficiently out of replenishment, out of reserve stock into your your pick face. You don't want to have to be doing half a carton, for example, and returning half an open carton into your reserve. So if we move on to the next slide, we then have a look at the actual logistics. We always like to look at the logistics, the technology, and the data. So we start off with the logistics. Replenishment equals 3 physical movements. The replen pick, which is the pick required to get replenishment product from reserve into the pick face, or I guess it's the first pick, getting it out of reserve. You usually have replenishment pick lists which are generated by your inventory systems. And then again, we're talking about these secondary reserve locations where you may be picking from a full case location into a split case location to save labor. Now, what we always try to do, and the mentality that I go into when looking at replenishment, is trying to see if you can pick directly into the warehouse unit that you're going to be hopefully loading into. So avoid any double handling. So, and that's where we kind of talk about now the ULD transfer. The second physical movement is actually putting it onto a handling unit that you can move it across the warehouse from the reserve location to the pick face. And then the final step is actually putting it to the pick face. Now, I've seen a lot of interesting solutions in this area. And, you know, with manual processes, it does come down to being quite smart about your operation. So you want to look for opportunities to replenish as you pick. The other day I was walking around an operation where they had a trolley, 2 levels. Level below was product that needed to get out to the pick face. The level above was orders that they were picking. So really simple, and they were just tasking to leaving. That's what they call that. And also, you know, it's kind of an obvious point, but replenishment is optimized when the pick face comes to you, as is what happens in goods to person. So if we go to the next slide. Now, we talk about your replenishment strategy. Your replenishment strategy is linked to your picking strategy. Replenishment and picking are, you know, completely linked to each other. So much so that a lot of organizations I know, they can't actually begin their pick, they can't waive their pick until they've replenished. So people often forget about replenishment picking and the labor associated with that. And it's at their own peril because eventually it becomes very much a focus. It doesn't get the attention of your outbound operation, but it's just as important. If you choose the right replenishment pick method, which most of the time it's some kind of batch picking, then you know you can actually do it as part of your normal pick if you're batch picking as well. You can have a batch for your replenishment and you've got a couple of orders next to it, just like in the example that we were talking about previously. It's all about maximizing labor and getting the most out of each move. Smart slotting is based on velocity driven and seasonality factors. And we can see there we've got the Pareto curve and we've got a heat map of a warehouse. You want to look at your data and understand what's your fastest moving product, the next moving product, and choose the right pick face for it. You should be reviewing your replenishment strategy on a monthly, if not weekly basis, depending on your operational profile. But once set up correctly, you can find that you'll be able to use your tools repeatedly to get different results out of them. Or this is where a slotting software can help and make that process more repeatable for your organization. So we'll go on to the next slide. We now have a look at the data and the planning piece. The replenishment process is facilitated by the following system processes. You've got replenishment triggers that are set at the SKU level and also for each pick face type. So there's 3 main types of replenishment triggers that I've kind of come across. One of them is a WMS-driven replenishment trigger, where you basically have a minimum level, a low-level trigger point for your SKU, and once the product gets to that point, it generates a replenishment trigger and you move on. Now, these are all obviously system-driven. If you don't have system-driven, you're going to have to find a report for yourself to help you manage this. Then the second one is topper. So this is when, instead of working on a low-level minimum trigger, you've got a high-level trigger, and you're always trying to maintain your stock above that trigger point, and it's more opportunistic. You're not kind of chasing your tail, but this does imply that you do have sufficient capacity at your pick face to do so as well. And then the final one is demand driven, where you might have so many SKU that they don't all actually have a pick face, and therefore you have to rotate SKU in and out of your pick face, and you constantly have to be replenishing for your pick, as per the example that I provided earlier. So that's where dynamic pick faces can come in and get quite a little bit more complex, but just require more managing. Then the second kind of process, that's a system process that's required, and where you're gathering data, is where you're doing the inventory transfer. So you've triggered a replenishment, you now then gone and generated the pick task, executed the pick task, and then right as you confirm that move into the pick face location, you do the final step, which is a stock top up. And then it updates the stock level, makes it available to pick, and you move on. Final point there, which you probably all read, is just about making sure that you are engineering that strategy, and as we mentioned previously, reviewing that regularly as well. If we can move on to the next slide. We'll start to wrap up just with the technology that's available in replenishment. Now, a lot of this stuff's been around for a while. You know, it's about getting smart about how much stock on hand you can hold at the pick face as well. And in the example that you can see on the page, you've got a mix of carton life storage, pallet life storage, and even the reserve locations above are using gravity fed, and you've got a conveyor down the middle, so you're picking. So it's all about, you know, they've chosen a specific type of pick, and therefore you maximize your replenishment to meet that. We've also got an A-frame at the bottom, which is what I call replenishment driven automation. This machine, you have to stock it up, and then you can run it full pelt for a couple of hours, and then it runs out of product. So full replenishment driven. And we're going to finish off in a couple of minutes. We're going to have a quick look into micro fulfillment centers, which are quite popular at the moment, and also what I classify as replenishment driven automation. So we can just go on to the next slide about technology. We are coming a long way now. You know, we're seeing the shuttle technology quite mature. So we've got decant stations, as you can see there on the top right hand of that slide. We can see, you know, 10 stations right next to each other for decanting, and they've got pallet lifters that are ergonomically placed the product so that you can decant into totes. And then the top level conveyor that you see there is a trash takeaway conveyor. So the carton's taken away almost a couple of 100 meters to a compactor, and that takes care of your waste. Your cardboard flows, and they're quite important to think about. And then we've got shelves now. The AMRs, we're starting to see these solutions pop up a lot more often. And these solutions, you're replenishing directly into a pick face that moves around. So you don't have to necessarily change your unit load as much as decanting into a tote. So it makes the thinking a little bit different. Robotics is also playing a part, but we'll just go to the next slide and just finish up the main section of the functional overview. So replenishment really is the cornerstone of outbound operations. Data-driven decisions are key to future-proofing your replenishment process. And, you know, we call it the art of replenishment, and it really is at your fingertips because it requires your management, your knowledge of your operation to make it really work. So hopefully you've learned a thing or two today, or, you know, refreshed what you might have already known. Now we're going to play a video about the Nova store. I'm not sure if that started playing just yet, but the Nova store concept redefines the definition of the future grocery fulfillment operation or supermarket. As we're flying in, you can see that there's technology everywhere. There's digital catalogs, there's self-serve stations, but there's still pick aisles. And there always will be, because there's a lot of product that we'll always want to pick ourselves. As we move through the store, it feels a little familiar. The aisles are there. It's the in-store convenience that we've become used to. There's kind of we've got another self-serve station over here. In the back corner, there's a cafe. I know that a lot of the supermarkets these days have cafes or little sushi places inside the supermarkets as well. And as the video continues to pan throughout the supermarket, it's futuristic, but it's not, you know, out of our imagination. And it's just all about the convenience factor that supermarkets are really focusing on. You know, we're seeing this push to have real convenient supermarkets and make the experience as convenient for the customer as possible, so that You know, that's basically the competitive advantage. But as we pan around the supermarket, we see that it's actually got a relatively low building height from what we saw as we were flying in. And as it pans over to the right, you see that there's an elevator shaft in the right-hand corner. And all of a sudden, maybe there's something different about this place. There's someone collecting some blue totes coming out there as well. And I saw this video for the first time early last year, and it really just helped me change the way that I think about how retail might look in the future. You know, it's now going to take us up another level, and you're going to see that, you know, this is what micro fulfillment is all about. It's about squeezing automated systems into unused areas of existing retail assets. Or sometimes, you know, you're just going to squeeze another area of that is used out of your supermarket or retail outlet, because it's going to make sense. But the future grocery shopping experience could be one where you confirm your online order as you walk into the fresh section to pick your fruits, veggies, and deli items. Then you self-checkout, and by the time you get to your car, the rest of your order has been delivered to an outlet right next to where you parked, and you're able to place those items into your boot and drive away. That's the power of automation. And on that note, I'd like to hand over to Paul and Graham. Thank you.
Thanks very much, Jeffrey, and hello everyone. Yeah, it's an exciting time in automation generally. I think, you know, it's not a new industry, warehouse automation, but it's certainly accelerated a great deal due to recent events. And as Jeffrey just showed, there's automation is no longer just something limited to the warehouse. It's also going to be popping up in store as well, and out the back of stores, co-located, etc. So it's a very exciting time to be in this industry. We're seeing a lot of new inquiries as a result of what's taken place and is taking place. And so I guess it's a bit of a silver lining that the logistics industry is facing an increase in activity over the coming years. So I'd just like to thank Graham Faulkner for joining us today. He's the COO of JCar, and really the key person, the key to contact for Swisslog at JCar over the last 4.5 years. We're about 4.5 years into a 5-year journey with JCar. It started 4.5 years ago with the initial inquiry. They had already decided to automate. They had a consultant on board, Bruce Drayton from DCL, and they were pretty clear on what they were looking for. They had actually attended a couple of technology days that we'd had out on site with various locations, and had obviously done the rounds and met a lot of our competitors as well. So they were fully geared up to run a tender for an automated warehouse. That whole process took quite a long time in the end. There was a change of site, which meant that the solution could be reconsidered, made smaller in footprint, and actually more automated than was originally planned. So that was great from our perspective, but it did mean that the process, which could have taken a year and a half, maybe maximum 2, in the end took 3 years to go from initial inquiry to start of project. So thanks, Graham, for joining us. Great to have you here and to talk about your solution. And basically, it's it's a perfect example of data-driven replenishment in an automated facility. So I think it's a good choice to look at, even though it's not completely 100% built yet. But we can also learn something from that, the fact that it's not completely finished just yet. So thanks, Graham, and I'll hand it over to you.
Okay, thanks, Paul. And yeah, good to be here. Just talk quickly about JCar for those that don't know who we are. We're a group of companies founded by Gary Johnson in 1981. We operate 2 retail brands and 1 wholesale. So we've got Roadtech Marine, which is an outdoor parts business, which we started about 4 or 5 years ago. It's now got 20 stores with a wholesale channel. And of course, we've got JCar Electronics, which is the brand name people will be familiar with. 120 stores across Australia and New Zealand. Dan, can you push the slides forward, mate? So cool. Yeah, so that's a little bit about JCar. You know, we've got a strong service-driven model in our business, passion for the products that we sell. If anyone out there is a JCar customer and JCar fan, you will know that we do employ guys in stores that know their product knowledge. Inventory and product to us is really core to what we do. It is all about stock for us, and obviously replenishment and getting it into a store is really key. We directly source, import, distribute the majority of what we sell. We're pretty obsessive about our in-stock position. We believe we're as good as anyone. We are basically in stock of everything. We tend to have a little bit extra than a little bit less. So we've taken a more conservative approach, and that's kind of partly due to being a destination retailer. You come to us with a problem, we'll sell you product and fix your problem. We also, do take pride in the new and innovative products that we source around the world and import into our stores. And the store you're looking at now is our new Broadway hub location. It's a new concept store. It's a maker space and a retail outlet in one. So you can go in store and do your electronics. There's actual places to actually use our products in store. It's something that we're proud of in Broadway in Sydney. So yeah, Dan, moving on, if you would. Okay, why did we decide to automate? We had strong plans. We understood where we wanted to be. We did, as Paul alluded to, have a bit of a change of plan and a bit of a reconsideration, which is something that we internally drove, or at least logistics side of the business drove. We were looking at a more traditional 40 to 45,000 square meter building. That's going to be we had actually 10 hectares of land to put that on. It then made a lot more sense to move that asset, condense down to 3.5 hectares of land and do a more automated high bay, low bay solution, which Paul will talk to shortly. I could demonstrate, strong internal rates of return. The finance guys got on board, the owner got on board, we got the capital, and we went for it. It's an enabler, automation, wholesale channel especially. We can move into more low-cost distribution models and do some things that we probably don't do at the moment. Some customers we don't, or markets rather, we don't really serve due to choice. With automation, that changes. And there's the changing retail landscape that, Jeff just, I guess, gave some insights into what is coming down the road. You've got huge growth in online. Obviously, COVID helped underline that in the last few months, but that's been happening. Our own online business, there's some new entrants to the market that we weren't focused on. Drop shipping models from China all drove our drive for automation. Dan, please. Swisslog. Okay, why did we choose Swisslog? Obviously, we did. So we felt that they had the best overall solution. The solution they presented was fully future focused, no legacy elements at all. So some of the bits and pieces that Jeff just showed us through around replenishment with carton life storage and things like that, we wanted to steer away from. At the time, I believe that they had the best shuttle in the marketplace, with an ability to handle variable width and variable width cartons, with a distinct advantage that they had. Full case picks now can be done without any human intervention. They had warehouse management system that was going to be fully integrated. That was one of the things we were looking for. And Paul and his team really did demonstrate probably the best and deepest understanding of our business, and help drive some of the innovations around some store-friendly deliveries, which I think Paul will talk to shortly. Yeah, that's probably a quick summary of where we're up to. We're busy building. Paul will talk to that in a moment. There it is. And I'll pass back to you, Paul, I guess.
Thanks, Graham. Yeah, so this is a It's pretty close to fully automated solution. There's still some tasks required, you know, in the manual warehouse. There's some things that we can't handle within the shuttle that are overweight or out of gauge for a shuttle. So there is you can see a manual warehouse component on the right-hand side, number 9. But I'll walk you through the solution, and as we go around, I'll give you a few statistics about it and explain what it does. So starting at point 1, that's the receiving area. It's about 1,000 square meters of floor space. Basically, containers arrive at the facility. They're loosely stuffed with cartons, and they're manually unloaded onto pallets on the ground. There are a series of checks done on the incoming goods, and then once the pallets are palletized, they are put into the automated system. That occurs just to the left of point 1. There's an overweight, out of gauge, pallet board check. Everything happens at that point. One of the interesting features of this pallet ASRS system is that all the pallets are captive within the solution. The goods don't arrive on pallets, or if they do, those pallets aren't used. So JCAR owns and was purchasing and it will own their own pallets within the system. Those pallets will also have RFID tags on them, front and back, for their identification. One of the reasons for doing that is that these pallets will be put away. Initially, they're wrapped and then they're put away, but then they'll be pulled out for replenishment multiple times during, you know, the stock life on that pallet within the facility. And each time that we pull the pallet out, there's a potential for some rewrapping required. And what we didn't want to have to do was reapply a label with a barcode or anything every single time that occurred. So in order to prevent, you know, wastage within the facility, which is something that the owner, Gary, is very keen on as well, from an environmental standpoint, we proposed that maybe the pallet should have RFID tags, and so they do. They also have nameplates on them, so you can identify them manually as well if needed. But basically, those pallets are captive in the system. They won't go outside the warehouse, and they just hold the product inside the high bay storage module. That storage module number 2, it's about 22 meters tall, so not as tall as we can go. We can go up to 40 or more meters, but certainly when you walk inside the facility and look up, it's quite astounding, even at 22 meters, how tall that is. And I'll show you some photos at the end of the presentation of the cranes being installed. Swiss Log manufacture those cranes. I guess that's what we've always been famous for in the past. And also we manufacture in Sweden the pallet conveyors. So the cranes come from Austria, the pallet conveyors come from Sweden. There's about, in phase 1 of this project, this diagram shows the fully expanded solution. Phase 1 has about 2/3 of the storage, or 1/2 in the cyclone and about 2/3 in the pallet. And the pallet storage module will eventually hold 30,000 pallets. As I said, 22 meters high. It's about 80 or so meters long and about 80 meters wide, so it's roughly a square in shape. It's similar, I guess, in area to a football field. So you don't get a perspective on how big it is until you're actually out there on the site. Obviously, it's a brand new building as well. So yeah, pretty impressive looking system when you go there. They're multi-deep cranes, so they can be 6 deep or 4 deep in some of the aisles. The reason for that being that some of the stock arrives in quite large quantities, and also the throughput demand didn't justify having, you know, double deep, triple deep, or single deep cranes. It just wasn't enough throughput there to justify that. So the most economic solution was really to go multi-deep, and that was understood pretty early on. So the pallets are put away once they've been manually palletized, and then they come out automatically. So what happens is basically whenever the shuttle needs replenishment, and that can be judged by sync based on historical data and also orders received and stock inside the facility, and also min-max settings for each SKU. So whenever something is running out of stock inside the shuttle, sync will trigger a replenishment request, and those replenishment requests are built up inside our log, and the cranes start to bring the associated pallets down. There's also pallet reshuffling done overnight to make sure that the required pallets for the next morning's replenishment run are at the front of the crane aisles and on one of the crane faces. We also have under point 3 there's a buffer, if you like, on the line. So before Graham arrives at work, or anyone else really, apart from maybe one operator walking around supervising the overall system, pallets will start to come down from the ASRS and build up on the automated line, ready for the morning's replenishment run. The replenishment takes place between the ASRS and the shuttle system, and then there's a goods to person system we refer to as a front zone in under point 5, and then there's QA and repack for ecom orders, and the ability to put in materials, marketing materials, etc. happens at point 6, and then at point 7 there's the packing stations, and I'll show this in more detail in a second. And then point 8 is just the dispatch loop. We dispatch by order and by destination. And then point 9, as I said, the manual warehouse. Point 10 is the offices there for JCAR. Next slide, thanks. All right, so moving on. Okay, I've already sort of talked about how the pallets arrive and get palletized, get wrapped. There's no need to label because of the RFID tag. They go straight into the ASRS. Then they come out on a as needed basis as determined by sync. There's no need for a supervisor to sit there each day deciding what to replenish into the shuttle. That all happens automatically. If you move on to the next slide. Okay, and next slide again. All right, this shows the replenishment workstation in more detail. So the pallets have arrived on that lower conveyor towards the bottom there, and they've queued up in the morning prior to the replenishment run. And then as soon as workers log on at their touch screens, there's up to 6 workstations there in the fully expanded solution, they will start to receive pallets to take goods out of and decant into totes, or alternatively put a full case into the system. There's also an out of gauge, overweight, over height check, basically a profile check for each tote and case as it's been loaded into the system. So each of those workstations has one of those. And if there's a problem, i.e. they've overloaded a tote and there's something sticking out, or if the case is too heavy or too large for some reason, it'll just return back to the worker. Another interesting feature of this replenishment workstation setup is that there are multiple lanes you can see in the middle with the blue totes on them. That's because these totes, a lot of them have got dividers in them. Not every SKU requires a full tote. And so we've got 1 by 1, 1 by 2, 1 by 3, 2 by 3, and 3 by 4 divided totes in there for various different sized products. You know, a lot of what JCAR holds is very small resistors, capacitors, tiny little devices. So those don't go into a full tote. That would be a waste of space inside in the shuttle. And what happens is that when the pallet is presented, it's also rotated and lifted up and down automatically. The replenishment worker can then take the case they're looking for as prompted on the screen, open the case on the table next to them, and then start to decant the items into the tote. The tote has already come automatically based on the identity of the product. The SKU master information carries what tote and location size is required, and that automatically comes in front of the replenishment worker, so they don't have to wait around. They don't have to decide what type of tote it should go into. All of that happens automatically based on cubic information about the products held within the SKU master. If for some reason they decide they want a different sized tote compartment, then they can also reject the tote that's in front of them and choose from one of the others. There's a constant supply of full empty totes, so they can do that. We also, as I'll explain later, we're replenishing by aisle in the system and by merchandise area. So they can basically flush totes that already have products for a different merchandise area, and we only present totes to them that they, we only present totes which are either fully empty or have products for that merchandise area that they're currently decanting. So as I said, the replenishment process starts early in the morning prior to the pick. We want to make sure that we've always got enough stock to cover the day's orders. It's possible, however, that orders will come in through the day that are larger than we have inventory for, and in that situation, we do have a process to do an urgent replenishment. So a pallet would come down urgently and be replenished. Okay, some of the other intricacies around replenishment here is that the pallets can also have multiple SKUs. They're not all single SKU pallets. Some of the pallets will also have what we refer to as pally racks, so like a steel frame built on top of the pallet to hold different SKUs as well. And not every case will be fully decanted. Some of them will go back on a pally rack or onto a pallet and go back into the automated system. So we don't have to fully decant, although we try to where possible. Initially, also, if we run out of stock at the pallet level, but there still happens to be cases of the product inside the case, inside the shuttle, the system will bring down a case automatically, take it down this empty lane and present it to a replen worker. They'll take it off the system onto a table, and then a tote will appear in front of them, and they'll replen from case into tote. So we're also sort of, if you like, changing the unit of measure or TU type of the goods at this workstation. So I could go on for another 10 minutes about all the different operations that are taking place here, but just rest assured it's a highly sophisticated replenishment system. Okay, moving on. This just shows a typical screen, a replenishment screen. At the moment, these screens are being finalized. There's little bits of information that sometimes customers need to have. Under point 1 there, the number of units of this particular SKU, a white iPhone and 6 in this case, and it tells the worker how many to replenish into the location. Obviously more than 2 probably. It's just an example. It also shows on the right side which location of the tote to put the goods into, and there might be instructions as well for the product depending on how it needs to be stored, any special requirements. The replenishment worker also does a count as they put in the items into the tote and confirms that on the screen. Moving on. Okay, going into manual replenishment. There is some manual replenishment from the ASRS. You can take pallets out and put them across to the manual storage area. There's also pallets being palletized manually and then transferred into that area directly into manual storage. So Sync, our WMS software, is looking after all of that. Moving on to the next slide. Okay, so one of the things that just back to that image of the store, sorry, briefly. Just one of the things that we did early in the sales process was visit one of JCar's stores. Not this one, that I don't think it was around then, but one of their more sort of traditional stores. And something that really jumped out at us initially was that each store had 7 merchandise areas. And I knew at that stage that the system that required exactly 7 aisles of shuttle storage. And so I just put 2 and 2 together in my mind and thought, well, what if we were to propose a solution where we store and pick by merchandise area for the store? The advantages would be that, as Graham mentioned, their staff are highly trained. They're not your average retail worker. These guys really know their stuff, and they have to spend a lot of time with customers answering a barrage of questions about every single product, and they have to know every product inside out. I know I've been to JCar myself just to buy cables, and they have an answer for everything. So what we wanted to do with the solution was limit the amount of time they have to waste effectively sorting goods when they arrive for replenishment, and then taking them to various areas of the store and replenishing them onto the shelves. If we could sort of halve the time required to replenish the shelves, that would create hours and hours each day of time that they could then spend more productively with customers, helping customers, and also make their lives a bit easier. So normally the goods arrive in a bit of a jumble and a few boxes, and they have to do a pre-sort to various merchandise areas, and then take those goods over and replenish the shelves. When we pick in this automated solution, those sortations, that sortation process will have already happened. Each shipper will have one or two or so merchandise areas dedicated to it, and also it's not just store-friendly picking, it's also product-friendly picking, and that we won't put heavy items on top of light items and stuff like that, anything that could get damaged. So we're fully sequencing the orders, the products to the pick station, if you move forward. All right, so the pick station shown here is really just sort of a concept level at the sales stage. We always knew that we'd do a mock-up and there would be some ergonomics and things that would have to be looked at. And so that process has taken place, and there are quite a few changes to the workstation as shown here in the works. But in principle, the elements are all there. It's a 1-to-4 workstation. The blue tote it has about a 1.5 second replacement time. So and that's partly masked by the picker as they're moving back to the tote, so they don't have to wait too long for the next tote to appear. All the totes that are appearing in front of them are for a specific merchandise area or so, as picked by sync, and also sequenced, as I mentioned, by the rules that are defined by JCAR in terms of how they would like to pack the totes, so the order shippers, sorry. Under point 3 there's you can see 4 order shippers. They're all carton type. They're open. This is not a tray and lid operation. This is a carton operation. These cartons go through an EQ machine downstream, and their height is adjusted according to what's inside the carton to avoid any wastage of cubic volume. There's also a pick by light system under point 5 there, so it shines onto the location in the tote that they need to pick from. They also have a very clear screen, as you can see there on the right, that shows what they're picking, an image of it, how many they have to pick in the blue arrow, and where it's going to, so which of the 4 locations they're picking to. We also try to spend as much time as possible picking into locations 1 and 2, so that there's minimal walking back and forth up and down that area there. Some of the workstations are a bit more dedicated. One of them is handling a lot of really small items, like I mentioned, resistors and capacitors and things. Those that workstation has 2 pick locations because it does take more time to pick those really small fiddly items. And there's other things happening as well. And those really small items are bagged before they put into a shipper and only placed on top of the shipper, inside the top of the shipper. So there's nothing heavy on top. There's a lot of other stuff going on in these pick stations. Cables come out that have to be cut to length and things. So while it is a dynamic 1-to-4 pick station, it's not what we would refer to as a super, like a high-speed pick station. It's not somewhere where the tote's popping up and they're picking an apple and it's all very, very fast. They would probably average about 12 seconds a pick on this. So, and we wanted to go quicker than that, but Graham's held us back because he knows the operation better than everyone. And in fact, he's even mocked up these pick stations in his own warehouse and picked his own products and has presented us with lots of videos to prove how long it would actually take to pick his products. So a lot of thought's gone into making this ergonomic, and it will be even better than shown there on the screen. Moving on. Okay, this is a video here quickly. There are some future enhancements planned for this system, one of which is potentially item pick. Yeah, it sort of didn't make the budget round cuts, but it's part of the future expansion planning. This is a machine learning item pick robot. It has its own head, can be configured in different ways. It doesn't have to be taught how to pick items. It just identifies an object on it. It doesn't need to know what the item is. Sync knows. It knows that it's presenting a particular SKU to the robot, and it tells the robot how many items to pick, and it just cycles them into the tote. So the robot doesn't know what it's picking. It's just looking for objects in the tote. Based on the type of object it sees and the weight it's told, it basically configures its head accordingly. If it makes a mispick, it basically changes its angle of attack and tries again. And any time that it learns something about that object, then it records that information and passes it on to any other robot. So it's a self-learning, machine learning robot setup. That's something that we will look to apply in the future at Graham's system, and I think that would be a pretty exciting addition as well. Obviously, the system's designed for expansion, for acquisition, or anything that might happen in the business going forward. It's about a 4,000. So yeah, it's fast. It's fast, but it's not super fast at the pick station, and it's doing a lot of interesting things in terms of how it picks the product. Moving on. Yep. So progress update, quick progress update. How much time have we got left? Probably a couple of minutes. So yeah, we're about 80–90% of the way through the install. I think it's mainly electrical work now at the moment that's going on. All the racking is in, and I think all the cranes are installed, shuttles are installed, the conveyors are installed, and electrical tradesmen are walking around wiring it all up. Moving on, next slide. Here you can see the crane being installed. It was probably a few weeks ago now. Big scissor lift, huge scissor lift in front. I certainly wouldn't go up on one of these. A lot of courage required to do this job, and only a few companies capable of doing it in Australia. There's a very nice image of the crane on the right-hand side, and the crane, the white crane our crane, if you like, the warehouse crane, is assembled on the ground and then lifted up into position by that boom crane, and then basically the scissor lift and the crane maneuver it into the rail location, so that's all taken place. So that's a real milestone in the project when the cranes go in. All right, so this is just another image showing down where the replenishment will be. Obviously, it's a bit of a mess at the moment, but it'll be cleaned up pretty shortly. Just on the left, the blue frame sticking out on the left is the wrapping machine. That's the infeeds on the left. You can see the pallet rack on the left, and then the cyclone shuttle rack on the right. So yeah, it's getting close to a commissioning stage. So yeah, I mean, Graham, do you have any other points to add about where we're at with the install?
No, I think you've got it about right. Yeah, we're about to start the commissioning, which is going to be a bit of a challenge. The current state of play with COVID and so on, but we've got plans to, I guess, get that done. No, I think you've covered the solution really well. There is a lot going on, as you point out, in terms of mid to large organization with many variabilities in its product and product range. You know, taking on an automated project like this. So I think that's some of the uniqueness around the project, is the intricacies around replan, the pick stations, the decant stations. There's a lot going on in the background that's data driven and passed down to you from our interfaces.
Thanks, Graham. And back to you, guys.
Great. Yeah, thank you so much for that. That was a really interesting insight into a current project, which I think is a great thing for us to see and understand this as an area more, and something that's happening, and the new technologies that are being implemented. So thank you very much for that, both. We've had a few questions come in, which is great. If anybody has any questions they'd like us to answer, now is the time. We'll be going over a few questions in a panel style discussion. I've just got a couple of them come in already. Just first one for you, Paul, actually. So how many of these shuttle systems have you implemented in Australia so far? I think you're on mute, Paul. You're on mute.
My apologies. So it's the second for Australia and New Zealand as a market. The first one we installed has been running for a few years now over in Auckland, and it's part of a case pick. How do you call it? AC pack, we refer to it as, but automated case picking system, which is operated by Coca-Cola Amatil. So certainly it's pretty exciting to have our first major shuttle on these shores. It will have, when it's fully expanded, 50,000 case or tote locations and around 200 shuttles inside, plus a few extra shuttles for maintenance reasons, to be able to pull one out and put one in pretty quickly when needed. So yeah, it's exciting to see a shuttle going in Sydney, and more to come, I guess.
Mm-hmm. Yeah, fantastic. And Graham, just one for you. What do you think the biggest challenge for the warehouse management team with the introduction of highly integrated automation will be?
That's a good question. I think key parts are going to be getting the quality of the inbound side right. We obviously directly import, and we don't always have absolute control over the suppliers and factories in China that we often deal directly with. So conformancy around the inbound side and what we'll do when things are not quite the way we thought they were going to be will be a key part of it. You know, a different way of managing the teams. It's going to be a lot more driven through the visualization within the sync software around the automation pieces, as opposed to our current, we have a split, well, 16 zone mezzanine, you know, routing system at the moment, zone-based routing picking system, but it's still on the ground kind of management. This is going to be, you know, more through your computers.
Mm-hmm. Yeah, I mean, I think Paul touched on it earlier. I think what's really impressive is just the range of different products you have. There's such a wide variety there that, you know, I'm astounded when I go into one of your stores. So I can only imagine the headache it must cause to create a warehouse. Yeah, absolutely. And when do you actually think this project will be finished and ready and good to be used?
Well, we're sort of targeting, well, we won't make this Christmas, which was always the plan. COVID's obviously put a few hurdles up in terms of getting equipment to site and also getting the right people to site. That's all being worked on. So we're looking at, you know, hopefully January, February, that's really where we're targeting. And there's some external factors which are outside of our control, which kind of limiting our ability to sort of accelerate at the moment. But yeah, we're doing everything we can to mitigate those challenges, I guess.
Yeah, absolutely. It's a very strange time.
Yeah, it's a strange time for doing a big project. Yeah, let me say.
Yeah, of course.
Yeah, we've had bloody bushfires and everything.
Yeah, it's been a wild year.
It's been a funny time, yeah.
Baz, just going to quickly go to you. Thanks for joining us, Baz. Just from someone that works across, you know, a variety of different platforms. So, how would you calculate the replenishment effort required for a shuttle-based automation system?
Oh, it's a good one. It's not a finite, simple calculation. It's not like it's an off-the-shelf thing that you do. Simply because these things have a finite capacity. So I'll refer to the back of your screen, actually, Daniel. You've got all this space around you, behind you in pallet racking. And pallet racking is sort of flexible. You know, you can put pallets on the floor if you really needed to. You can shuffle some inventory around. Shuttle systems are finite. They hold a finite amount of totes, so to speak. And if you fill them wrong, you can actually just overstock them. It's very hard to get stock out again. Mm-hmm. So usually what we do is we look at, you know, historical data of what you've done in the past. You look at forecasted volumes based on what you think you're going to sell. And a lot of it comes down as well on just common sense. So if you consider that most of these systems are based around, you know, slow to medium moving items, you can't put too much of a single item in. Otherwise, you're going to take stock away from something else that requires to be put into this as well.
Yeah. I mean, it just seems like there's so many moving parts with this process. That's what I'm really learning from this series. That it seems to be that everything has to work together, you know, very uniquely, and it's a smooth process to make it the best and most efficient process as well. Graham, actually, that's a good one to move to you for. So, when you're creating something like this, what do you think will be the biggest challenge for the warehouse management team with the introduction of such a highly integrated automation? I mean, do you find it difficult to then to train them up on how to use it?
Yeah, I guess the staff training piece is ahead of us. We've got experience from Swisslog to lean on. Our current facility is somewhat automated. You know, we've PDTs and conveyors are not new to us. The disciplines around the shuttle system and not being able to sort of take any shortcuts will be interesting to see. You know, as Baz was sort of intimating, you know, pallet rack or traditional, more manual solutions, that you do have a few ways to get out of jail. I think in a more automated facility, you sort of don't. So you need to think ahead and get it right first time and not try and recover, I think.
Yeah.
There's a lot of discipline required, I think. But I think that's also where Industry 4.0, it talks a lot about, being able to use data more effectively and to know, what makes sense in terms of replenishment based on historical averages and how much is going to be ordered tomorrow and the next day. You don't want to be overstocking too much. It's a balance, because at the same time, the less stock you put in, the more replenishment tasks you have to complete, so more effort. So there is a balance, and I think that's what the software is designed to look after, with the ability for the supervisor to override for certain events, or a run on a particular product that we don't know about. But yeah, it's definitely, this is an example of an Industry 4.0 problem being solved.
Yeah, we just had a question come in. I'm not sure actually if what you just said answered that question, but it says, what were the factors of considerations when choosing between auto store or shuttle? Was it speed of picking, variety of SKUs, or other factors?
Yeah, I could show you a chart where clearly it's a shuttle system. It was always a shuttle system. I think, Graham, you might remember, I think you were a little bit disappointed when we showed up and told you we would not be offering an auto store, because I think you were quite intrigued by auto store.
Yeah, I do. Yeah, I love it. It's such a brilliant implementation of technology and and space. I mean, that's the one thing that about the auto store that I just love the utilization of space.
Yeah, and it also made life a bit harder for me too, because I wanted to win the project and I knew I'd be up against a lot of other shuttle systems. So I think an auto store would just not have been fast enough for the number of SKUs and the storage. This was going to be in phase 1 a 25,000 tote system or so, and needed 44,000, a combination of cases and order lines picked as items, but 40,000 order lines per hour. And that would be too quick for that size of auto store. So it was always going to be a shuttle, but certainly made the sales race quite interesting. And we had to think a lot about the customer, as we've demonstrated today. It wasn't a simple thing to win this solution. There are a lot of very capable companies that we were competing against. So yeah, it was more about just trying to learn the business and how we can help the business. And that's what we've achieved, I think. We'll achieve.
Fantastic. Great. All right. Well, I think that's pretty much bringing us to a close. Jeff, just have you got any thoughts? I mean, obviously you introduced us to this section. Is there any thoughts that you have just hearing what people have said so far on this section of replenishment?
To be honest, I feel like everyone's covered it quite well. It was a really awesome insight into a system that is very much replenishment driven. So thanks to Paul and Graham for their insights today, and thank you to everyone for joining us.
Fantastic, excellent. All right, well, yeah, just to echo that, yeah, very much appreciate everyone joining us this week. We will be again joining you again in a couple of weeks' time with our partners Dematic. So make sure you join them. We'll be sending out the email for that next week. If you have any questions, please get in contact with either myself or the Fuzzy Logics team, or alternatively, we'll include the details to contact Paul or Graham directly if you have any questions for them as well. But thank you again. Thank you very much to the speakers for today, and look forward to seeing you all in a couple of weeks' time. Thank you all.
Thank you.
Thanks. Cheers,
Thanks,
guys.
everyone.
Thank you.